So I'm going to do this one the way the chapter intends for us to do, with implicit differentiation. But you don't have to use implicit differentiation. You can divide both sides by x to the 1/3 and then raise both sides to the 3/2 power, and then you've got y in terms of x once you get rid of that 10. So you don't need implicit differentiation, but that's what they're really trying to get us to do here. So if we're to find dy dx, then we need to take a derivative of this term with respect to x, and that does need implicit differentiation if we're going this direct route. This is a term in terms of x, and then y could be written as some function of x. So there are two distinct functions of x. That means we need the product rule. So the derivative of this first term with respect to x, sorry, I gotta type it out, is going to be 10/3 x, and then the power of x is now going to be -2/3, because when you take a derivative, the power gets reduced by 1. 1/3 minus 1 makes -2/3. And then the second term is kept the same, right, with the power rule, with the product rule. We took a derivative of that first term, the 10x to the 1/3, kept the second the same. Now we add the first term kept the same, times the derivative of the second term. So that 2/3 comes down, and then y is reduced to -1/3 power. But then we're not done, because we took a derivative with respect to x. So if y is some sort of function of x, then we need to multiply this. I think I'm missing a parentheses. No, I just have an extra parentheses there. Y is some sort of function of x, so that's the derivative of y. That comes from the chain rule. We took a derivative of the outermost function. The 2/3 comes down, then it gets reduced by 1, so that's our new power. But then the derivative of y isn't 1, because we're taking a derivative with respect to x. So it's y prime. And then it's all equals 0. Okay. Because when you take a derivative of 120, it's a constant, so that's 0. So it's pretty ugly. We can clean it up though. So this one is as clean as it can get. This term over here, I can move the constants out front. So 10 times 2/3 makes 20/3. Then that's x to the 1/3 power. We've got y to the -1/3 power, and then we've got y prime. And then I can make this equation simpler by multiplying everything by 3, because that'll get rid of the denominator and the coefficient here and here. So it gives us 10 x to the -2/3 times our y to the 2/3 plus 20 x to the 1/3 times y to the -1/3 times our y prime, which we're trying to solve for. And then to keep trying to simplify this, let's get the y prime term by itself. So I'm going to subtract this from both sides. So this is what you get when you subtract it from both sides. And then still trying to make it simpler, so we got x to the 1/3, y to the -1/3, so that's not super nice. Let's raise, let's see, what can we do? Let's multiply both sides by x to the 2/3 power. And I chose that so that I don't have negative exponents on x now, because x to the -2/3 times x to the 2/3, the powers add to make 0. What I do to one side, I have to do to the other side. And conveniently for this problem, it gives us x to the first. That's gone. That's now x to the 0, which is 1. That equation just got a lot simpler, right? And then we'll do the same thing in this step. Let's multiply everything in the equation by y to the 1/3 power. And I'm not pulling that out of thin air. I'm choosing it because I don't want negative exponents. So if I multiply this by y to the 1/3, the powers add to make y to the 0. And then conveniently, the way that Webenstein set this question up, that gives us y to the first over here. So we're even closer to getting y prime by itself. We just need to divide 20x from both sides. So we got -10/20, that's 1/2. -1/2, sorry, so that should be a negative sign up front. And we add an x in the denominator. So when you divide both sides by 20x, that's what you should get. So that's the first part. That's dy dx. Again, let's see. No, that's probably, I think that's what they wanted. So good thing I didn't do it my way, because it's in terms of y. But I think that's what Web of Science is looking for. I'll check after to make sure. But that should be dy dx. And then evaluate dy dx at the point 27, 8. That just means you need to plug in 27 in for y. Okay, I get that backwards. 8 in for y. And then 27 in for x. That's -8 over 54. Can I simplify? Yeah. That's -4 over 27. I think that's as small as I can go. Then interpret the result. Here, one second, let me. They just ask you to round this to 4 decimal places. So that's -1.4, -0.1481 it seems. And then B says interpret the results. Oh, I just kind of gave them the answer. But y is x is in terms of thousands of dollars, and y is in terms of dollars spent on capital. So it must be in thousands as well. It doesn't say that. So when x is $27,000, when $27,000 is spent on labor, which is what our x variable is, dollars spent on labor, and when $8,000 spent on capital, the amount spent on capital with respect to amount spent on labor is decreasing, and that's because we got a negative slope. We'd say increasing if that was positive.